in its unit place. So the word unit. So unit stands for 1. So unit stands for 1, O-N-E, 1. Is it? That's why you say the standard quantity means the unit as its numeric value as 1. As we just got from here, we just go out of this because we were supposed to know why it was called a unit that I was explaining. Now say you read just now that length was 5 centimeter. How it is 5 centimeter meaningful? How is it meaningful? It is meaningful like 5 is a numeric value. Multiply with this centimeter stands for 1 centimeter. That's why 5 is called the numeric value. That is called n. And this 1 centimeter as a whole is called u. It means length happened to be, this length of the body happened to be 1 centimeter added to 1 centimeter to added 1 centimeter added 1 centimeter added 1 centimeter. That is 5 times this unit was added. So it is called a unit. It is added 1, 2, 3, 4 and 5 times. That means if there is a scale of value 1 centimeter, you can measure a length of 5 centimeter body by placing it one by one at 5 points, at one by one at every ending point. Then only this scale will get you the 5 centimeter length. So is the meaning actually called what? Length is numeric value into unit. Unit is centimeter because we never use the term 1, but 1 is there. 1 is there. So 1 centimeter is 1. This 1 cannot be replaced by any other number. Centimeter with, I have written 1, that means this 1 cannot be replaced. You cannot write 2 centimeter over there or 3 centimeter over there. If it is, say, force is equal to, you say 5N. Why 5? Say 25N. 25 Newton is the value of force. That means it is 25 times of the unit of force value as of 1 Newton. That is 1 Newton force is applied at one time. Then if 25 same unit value is applied to the body will be under the effect of 25 Newton. So is the meaning that how many times in the definition, go to the definition again. How many times the standard quantity, that is unit, is contained in the physical quantity. The physical quantity of force is containing 25 times of its unit as 1 Newton. What is that? Force quantity, physical quantity called force, is containing the unit 1 Newton 25 times. The quantity of substance is called MOLE, mole, which can be written as MOL as well and MOLE as well. Both are acceptable. MOLE as a full term, on short term it can be MOL, just skipping E from the last, or you can even put in. The angle, it is measured in radian. So it is symbolized as small rd, and solid angle is marked as a steradian. Of course, S letter should be small and it should be STRD to be written like. So these 9 are called the basic or fundamental quantities. So fundamental quantities are those which are most fundamentally accepted and cannot interchange. They can generate many other quantities, but they cannot interchange themselves within their same bracket, within their same field. They cannot interchange. So they are most original, most basic, most unique, and most perfect in their existence, in their presence. So they are fundamental or basic quantities. What is the other quantity as well? The next or the other quantity. It's a very small word there, very understandable word is there. That is called derived quantities. Derived quantity. The word derived means the one which is produced, which is taken out, which is reproduced, or which is just taken out from the original. That means they are the combinations of these fundamental quantities. Means by recombining in a multiplicative or in a divided forms, in the forms of powers, they are actually derived, they are actually extracted, they have been actually taken out, they have been actually reproduced. So they are called derived units. They are very simple of saying. Go very fundamentally, say area. Area happens to be called length multiplied with breadth. Breadth is also a kind of length in its own meaning. That means it is length into length. Because breadth is also nothing but a length. That's why you are getting it a length to the power 2 if you say length as a variable. So normally we write it here as L to the power 2 as for area. So when you go for its unit, that unit will also go multiplying. That means the unit should be, its unit should be meter into meter. Then meter is become now a variable. That's why meter into meter becomes a meter square. A smaller than light year it can be. Because year is a time unit. Can it be a light minute? Can it be a light minute? If you can, do it yourself, then check from your textbook. It can be light second as well. Do it by yourself. Speed into time by having the same figure out for light second. So light year as a unit. So light minute and light second can also be the units. Do yourself, and then it is not that difficult. If you go by this formula, if a light year is speed of light in 1 year, what should be the formula for light minute? What should be the formula for light second? There is another third very popular unit coming called Parsec. P-A-R-A-C-C, Parsec. It is actually a short form of an elongated one. It is actually called parallactic second. parallactic second, it is called, which is defined here, the distance from where the semi-major axis of the Earth, orbit of the Earth, as value taken as 1 astronomical unit, subtends an angle of 1 second. This 1 second angle is not the value of the time. It is the value of angle as 1 second. It is a value of an angle called 1 second. So the semi-major axis of the orbit of the Earth makes an angle at a point of 1 second in the telescopic lens of the eyepiece or in the human eye. That distance, that celestial distance, timing is called the parallactic second, and so it is the measure of its distance. So light year is not a unit of time, it is a unit of distance. Astronomical unit is also a measure of distance. So is parsec, as parallactic second is also a measure of distance. And you can calculate it in terms of light year, very simple formula, that 1 astronomical unit is the multiplicative product of 1 parsec with 1 second. And that way, in your book there is written 1 and double dash. 1 and double dash is written in your textbook. This 1 double dash is called a second. And 1 parsec into 1 second gives you the value of 1 astronomical unit. And that way you find to calculate. These calculation steps you must follow in yourself. And do calculate by your own figure. And lastly you will get 3.266, almost 3.27, but here it is given 3.26 light year. That is 1 parsec value in direct objective answers. You can make it prepared for yourself as 3.26 light year. That way, I think you should be properly working out. Other than that, there is smaller units as such. They are also units measuring very, very small length, which cannot just be measured with the normal scales, whatsoever fine it is. It is to be measured by very microscopic scales as such, and they are the wavelength of light. That can be intermolecular distance, also can be the distance of the orbit of any nucleus or any atom from the nucleus. These small distances are measured also in terms of 2 very popular units. One is angstrom unit, ANGSTROM, angstrom unit, and one is Fermi units, FERMI. So here I name very, very small distances. Measure of small distances, measure of very small distance as wavelength of light is measured, as the intermolecular space is being measured like that. Very small distance is measured, called angstrom. That is the name of a unit, written as A0 on top as that, not a degree, rather it is a 0 on top. It is angstrom unit, which is a value of 10 to the power minus 10 meter. It is obsolete. Now it is not being used very much. In place it is taken as the nanometer. In place of this 10 to the power minus 10 meter, it is now converted to be in that nanometer term as 10 to the power minus 9 meter. This angstrom unit is now come out of our calculation scales. It is a nanometer also used. Nanometer is also used as it is 10 to the power minus 9 meter, as it is a nanometer.